In this example, we will again use trig substitution, although it may not be obvious right away. Let's rewrite that rational exponent in the denominator in a way that looks a little more familiar. We can rewrite that as the integral of dx divided by the square root of x squared minus 1 quantity cubed. And now we see the familiar variable squared minus constant squared under the radical. From here we can do the substitution. That is x equals a, which in this case is 1, secant theta. Then dx is secant theta tangent theta d theta. Now we'll make the substitution, the integral of dx. Replace dx with secant theta tangent theta, and I like to put d theta on the outside. In the denominator, we have the quantity square root x we're going to replace with secant theta, so that is secant squared theta, then minus 1, and that entire denominator is being cubed. Next, recognize that in the denominator we can use a trig identity to simplify. So I'll just copy the top. Secant squared theta minus 1 is tangent squared theta. That means we have the square root of tangent squared theta and all of that cubed. Keep d theta on the outside. We now have the integral of secant theta tangent theta divided by the square root of tangent squared theta is just tangent theta, and then it is being cubed. We can reduce one factor of tangent, so we'll get rid of 1 in the numerator, and in the denominator it'll be tangent squared theta. We now have the integral of secant theta divided by tangent squared theta d theta. At this point, I'm going to rewrite the numerator and denominator to help us see the simplifying that's happening. We have the integral of secant. Secant, remember, is 1 divided by cosine. So we have 1 divided by cosine theta, and then tangent squared theta. That is sine squared theta divided by cosine squared theta and d theta. At this point, we have a fraction divided by a fraction. Remember, to divide fractions, we keep, change, flip. We're going to keep the numerator, change division to multiplication, and then flip the denominator. I'm going to ignore the integral for a second. We have cosine theta, the numerator, change division to multiplication, and then we flip or get the reciprocal of the denominator. That is cosine squared theta divided by sine squared theta. One of the cosines will go away. We now have the integral of 1 times cosine theta is cosine theta divided by sine squared theta d theta. Use substitution time. U is equal to sine theta. Then du is cosine theta d theta. Rewriting the integral, we now have the integral 1 divided by u squared du. Think of that as the integral of u to the negative 2 power du. Integrating this, we get negative 1 divided by u plus c. That is negative 1 divided by sine theta plus c, or negative cosecant theta plus c. We're almost done, but notice the variable is in terms of theta. We want it to be in terms of x since the original integral is in terms of x. Let's now set up our triangle. Let's call this angle theta. And go back to one of those first substitutions we made. We said that x is equal to secant theta. And really it was 1 secant theta. So we can think of this as x divided by 1 equals secant theta. And then the trig rule, so katoa, will help us label the triangle. Secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, secant would then be hypotenuse over adjacent. That is x being the hypotenuse, the adjacent side is 1. We can then find this missing side using the Pythagorean theorem. We'll get the square root of hypotenuse squared minus 1 squared, which is just 1. Going back to what we have here, now we're looking for cosecant. Cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, cosecant will be hypotenuse over opposite. So the hypotenuse x divided by the opposite, square root of x squared minus 1. And remember that it is negative, so we'll just put a negative sign out front, and plus c.